Welcome, everyone. Welcome and happy solstice to our Academy explorers and delegates and fans. I'm going to spotlight my video because we're on Chris right now. And to all of our fans and friends, welcome to our virtual classroom. My name is Teresa Collins, and I'm the director of the Resonance Academy, and we're excited to welcome you into our virtual classroom for this special solstice gathering with Nassim Haramein and members of our Resonance Science Foundation team. This virtual classroom is the place where our delegates get to spend time each month with Nassim in our monthly Live with Nassim sessions, with our Academy faculty in our monthly faculty Q&A sessions, and they get to connect with other delegates from around the world in our community breakout groups. And this virtual classroom is one of the highlights of our delegate path. So today we wanted to open up this space on this beautiful solstice day, it's really beautiful where I am, to the public so that we can share this experience with you, our friends and fans. So I'm just going to explain a little bit about our Zoom system. You can see there's a place for you to chat. And if you're just coming on, please take a moment to put your name in the chat and where you're calling in from. That's a really nice way for us to see who's here. We aren't going to take too many questions today because we have a full offering for you. But if you have questions, you can put them in the little Q&A section you'll see down at the bottom. And that way we can keep the questions separated from the chats. The chat's the place where you can put any kind of comments or anything that you'd like as we're going through the session today. We have a great session planned for you where Nassim and our research team will be sharing some of the breakthroughs in science from this year, as well as some of the research that the team will be focused on in the new year. And I know every time I hear something new that they've discovered and they share it in our virtual classroom or in our lounges in our delegate program, I really get to change my experience of who I am and my relationship with the universe and the world. It's always really an exciting thing. So you get to sit back and relax, open your mind and your heart as we join our energies today in resonance together. And my hope is that you are both inspired and nourished by our time together. So I'm going to start this session by introducing Chris Almeida. He is our Executive Director of the Resonance Science Foundation. I wanted to have him come on, say hello to all of you, and just have some opening words on this beautiful solstice day. So Chris Almeida, thanks for joining us today.
Absolutely. Thank you, Teresa, for opening up this call. You're always such an amazing facilitator for these calls. Every time I hear you speak, I get inspired about what I thought I was going to say, and then I say, oh, that's such great stuff. So very excited, as always, to join with all of you on this what's become an annual event for us, this winter solstice call. And it's I've had the opportunity to reflect on this past year, and I was looking at what we were doing last year at this same time. And I looked back and I was like, oh my gosh, it was the connected universe. We one premiere after another from late September going all the way through to December 13th, ending in Mexico City just before the winter solstice call. And we were kicking off a year of connection centered around the connected universe. And I never could have conceived at the beginning, just before, at that winter solstice, what a year of connection we would have truly had, how we really resonated and completely embodied that principle of becoming more connected as a community, as a staff, as a family, as team members. I mean, even today, at the end of this Mercury in retrograde period where everything's going crazy all over the place and there's chaos and you're like, what's happening? Everything is just moving in a more connected fashion, and things are falling off in the way that they need to fall off. So I've been really inspired by that when I was thinking of that connection. And I'm not going to spend a long time of that, but it really, the synchronicity of the announcement that I want to make to you now is just perfectly aligned from that perspective. Because, we've spent a lot of energy with Egypt and the delegate gathering and connecting together physically. and really, really strengthening our community and that connection. And now, in the perfect timing, the Connected Universe just became available today, an hour ago, for pre-order on iTunes, which is amazing.
Wow.
Wow, great.
It's very exciting. So you can pre-order it today for $9.99. It's a special offer all the way up to its premiere on iTunes, which is going to be on February 14th, 2018. And this is one of the largest platforms in the world. And it's been, a dream of ours to really get this movie out to a much wider audience in a way that we just didn't have the resources to do. So this is a huge completion of the circle from last year's Solstice, of where we began on our adventure of connection and where we've arrived at. So I'm going to post the link in the chat as soon as I quit jabbering here for everyone. So you guys can go check it out if you have Apple, or you have iTunes, and you can see it there. And that's just the beginning. There's more announcements with the Connected Universe film that are coming. So this is going to be a year where it's almost like a relaunch. We launched to our group, we launched to our community. Now we're going to take it to a whole nother level. And we're going to launch it out globally on a much, much bigger way, on a much bigger platforms. So it's so synchronistic and very, very exciting to me, and just a harbinger of everything that's to come in 2018, as well as what you're going to hear on the call today with the research staff. That just follows on that idea of connection, because I know you see these guys in faculty calls and you hear about the research division and you hear about the research staff, but you don't always get to connect with everybody all at once and really see the full depth of the incredible people that we have that form the nucleus of all this work. Without research, we're all standing on air. There's nothing there, right? So it's the theoretical work that is the most fundamental kernel of everything that is the Resonance Science Foundation, that is Taurus Tech, that is the Arc Crystal. All of it stands on these people's shoulders. So it's great that we're really going to get to connect deeply with all these people today, and for you all to get to know them better. So it's going to be an amazing call. Stay tuned. Tell your friends, hey, it's live right now. It's live on Facebook. Join in with us. This is going to be a great way to close out this year and to kick off 2018. So thank you.
Thank you, Chris. That's so exciting. You didn't even know that a few minutes ago when we were talking that it was ready to go. So I'm so excited it happened now. Surprise. And I'm loving seeing where everybody's calling in from. Like, look at the chat and just see where we're all from. And one thing about the solstice and the equinoxes I really love is that in the northern hemisphere, where we are right now, where I am anyway, it's a winter solstice. And on the other side, in the southern hemisphere, it's summer solstice. And I always love that balance is always present on the planet. So for those of you that are beginning your summer solstice, we send you a lot of blessings. And for those of us on the northern hemisphere, for our winter solstice. So I'm going to get Nassim on next. Let's spotlight your video, Nassim, and you can unmute your line. Hey, Nassim. So happy to have you on today. Happy Solstice.
Happy Solstice. It's great. Another spiral around the sun. Wonderful. It happens so fast. I tell you. Nowadays, days are accelerating. It's just because we have so much packed in one day, it's amazing. In our modern time. And so it feels like the days go by so fast. And at the same time, it feels like, a day is so packed, it could be a year. But I'm grateful to be here on this amazing solstice. I think it's a really important one. I think this year of 2018 is going to be critical. Solstice is the time of the year for rejuvenation and transformation, and I think as well, of really building on the energy of all these religious rituals that occur at this time of the year, and instead of seeing them as maybe outdated and not necessarily appropriate and so on, let's interact with them in a way that is more positive. Let's look at them as a positive gathering of soul, gathering of spirits. You know, all the people around the world connecting with their family, connecting with their friends, having an amazing time, sharing amazing feasts, and you know, let's think of this moment as like an opportunity to like send a message across the, you know, morphogenetic field of the planet, the across the universal network, that humanity is rising. Humanity is actually, you know, birthing itself into a new way of interacting with the world, a new way of being, a new way of experiencing the universe and experiencing themselves as something part of the universe, something that is deeply and fundamentally connected to all things in the universe, that's part of an amazing will work that has critical impact on the evolution of the whole, not just a part. Not that, you know, that we're separate, that we're insignificant, but that we are part of an incredible structure, an incredible network that is now being discovered, and that is now as well being identified in physics very clearly by many physicists working on very advanced theories, and certainly some of the physicists I'm about to introduce to you that are part of our team, that have been working with us and working diligently, and that are like the kernel of one of the, you know, most important endeavor in physics, I believe, which is to identify a very clear, unified view of physics from the quantum level to the universal, you know, cosmological level, and to identify the mechanics of this interconnection between the very small quantum world and the relativistic gravitational world of cosmology. And as we do, of course, it opens path to deeper understanding of ourselves. As with William Brown, we have started to publish papers about the relationship of consciousness to this new worldview of a network universe, but as well to engineering path and technological development, which we work on in our laboratories and in other laboratories, sisters and brothers laboratories around the world, you know, in parallel. And so there is very exciting technological and philosophical adjoint to these papers that our team is about to publish. Some of them that has to do with cosmology, and some of them that has to do with quantum physics, and some of them that have to do with both. And so, you know, let me just turn it towards them, you know, and let's before we do this, let's just think of the connectivity of all of us on this call and our power together, our power to exchange information through this medium, but not only through this medium, just through the natural network that makes up our body, for instance, this incredible miracle that we call our body, to like 100 trillion cells, you know, that are in perfect relationship with each other, so that billions of chemical change every second can maintain high level of coherency in a very complex metric, in which each cell is made of 100 billion atoms themselves. And to think of that network at that level, that makes up your existence at the very deep level of your existence, and that network being quantumly connected through wormhole structures at the quantum level to all of the network around you, to all the atoms around you, to all the structure, and not of just the material world around you in which you're exchanging information, but all over the world, all over the solar system, all over the galaxy, all over the universe. And as they are all entangled with each other, as we're discovering in this new cutting edge physics that's occurring with our team, but not only with a team that is being developed as well by very advanced teams of physicists all around the world at this point. So that was my little 2 cents.
Well, who do you want to introduce first, Nassim? Which one of your researchers would you like to introduce first? And I'll spotlight after you do the introduction.
Well, we should start always with the one that's the most shy, Amira Val Baker, and definitely a senior researcher for our team. I work closely with Amira every day. Amira holds a PhD in physics, astrophysics, and she's a small package but mighty. And I think people that have been able to connect with her and has got to meet her really appreciate her mind, her capacity to compute and analyze, and as well to actually see the picture from a very holistic perspective, which is actually challenging for many physicists, because we get trained in studying physics, in studying very narrow sections of physics, and not to wander out of these narrow boundaries that are defined in various fields of physics. And Amira is able to pull out of that and outside the box and see the larger picture. And this is why Amira was hired in the first place, and why. And that, we had hundreds, or at least a few tenths of applications from physicists all around the world, some with significant experience and seniority over Amira. But when I hired Amira years ago, now the reason I did is because most of these other physicists, when we would have the interview, eventually I would ask them, so what do you think of the holographic mass solution? And every single one of them said, in general, said that they needed me to help them go through the papers because they were having a hard time with it. And I was the only one that said, oh my God, it's so brilliant. And it's so simple. I can't believe people are not getting it, and so on. And so it was right away, I knew that Amira, was able to see the bigger picture, was able to break through the paradigm that she had been taught and see other paths as viable paths. And so here she is, Amira Val Baker. You're muted.
I'm unmuted.
That's a great introduction. I just unmuted you. Hi, Amira.
Hi, everyone. Happy Solstice. Thank you for that lovely introduction, Nassim. That was very lovely. I hope you can all hear me okay.
Yes.
Yeah. Well, first I'd like to say it's wonderful working with Nassim. From young, I was always interested in how things worked and the relationships between everything. I mean, like most young children, you're always intrigued by these things, and I was always fascinated by the patterns that you could see, and I just wanted to relate all these patterns across all scales. So when I came across Nassim's work, it was amazing, because he had this geometric solution that could explain all these relationships. So when you see these patterns, you now have this this geometric model which can explain these patterns. So for me, I have this fun job where I just get to look for all the patterns and use this theory to explain it, because we can, well, what I believe and what I hope is that we can we can extend this theory and apply at all scales across all aspects of physics. So it's quite a big job, but it's very fun. And for those of you who don't know, for the last year, we've been working on the electron solution. Now that was, we published a paper, so some of you may have read that because it's available on the website, and some of you may have seen my presentation in Egypt, so you may know a bit more about it. And Nassim has talked about it on numerous occasions. But in case you don't know, it's basically an extension of the proton solution, where you're thinking of the electron as a cloud of potential emerging from the proton and from the Planck, the co-moving Planck scale. And it was amazing, because when we applied with this understanding, and when we applied the generalized holographic solution of Nassim's, we were able to get an exact mass for the electron. And this was pretty significant, because it's a really good example of how this solution is not only valid at the scale of the proton, but it's also valid at the scale of the electron, and most probably valid at all scales across the universe, and all aspects of physics. So this was really, really amazing when we did this. It was really inspiring. And in fact, actually, we had already, before this, we were working on, well, you can see behind me, we were working on the vacuum catastrophe way before we got sent off on a tangent with the electron. And this, the vacuum catastrophe is the apparent 122 orders of magnitude discrepancy between the density at the cosmological scale and the quantum scale. And this was resolved with the generalized holographic solution, extending from the proton to the cosmological scale. So this is two good examples of how this theory of Nassim can be applied at multiple scales and multiple aspects of physics. So I'm hoping this next year we can extend both these projects. For example, the electron, we're looking at the ionization energies of the electron. This is the amount of energy that's required, the amount of energy that's needed to remove one electron's worth of energy from the system. So you would think that's pretty straightforward, but it's not exactly straightforward, because it depends on where you're perturbing the system and the system that's being perturbed, like what atom you're perturbing. So there's lots of different aspects to it. It's not as straightforward as it sounds, and this is the reason why the standard model hasn't been able to solve this and cannot make these predictions. So we're hoping, with the help of Ines and Olivier and William, we all met with Nassim, obviously, over the summer, and we had a workshop where we all discussed this, and we're still working on this together. We're trying to use this generalized holographic approach, this unified physics model, to solve for this and to be able to make predictions of the ionization energies, which the standard model can't do. So that's a lot of work in itself. And then as well, like I was saying, we'd like to extend this model to all other aspects of physics, like dark matter, which is hot news at the moment. Everyone's talking about dark matter. So that's another project that we'll be working on this next year. And where's all the missing matter from the sun? That was another research paper that came out. So maybe the unified physics model can explain this. Or dark energy, for that matter. No one really knows what dark energy that is. It can't be explained. So all these aspects we're going to be working on for the next year. And hopefully now with the team we have, and maybe even more team members that will join us in the future, we'll be able to get this work done quicker and faster. The more minds, the merrier, they say. So it's going to be an exciting year. And I'm looking forward to seeing what we can all do together. So thank you.
Thank you, Amira. I'm really looking forward to having you more on our faculty Q&A calls, and your presentation in Egypt was fantastic, and I know people want more from you this year, so let's make that happen.
Okay.
Thank you. All right, back to you, Nassim. Do you want to make any comments there or introduce your next researcher?
Yeah, well, you know, some of the things that that Amira was discussing, I mean, we've been working on since, I mean, the cosmological paper we've been working on since 2012 or 13, and it's exciting. I mean, on the poster behind her, we were solving for some significant values very accurately for the dark energy in the universe and its expansion and all this. So all the things she's talking about, we're working on. It's remarkable how long it takes to write these papers. Of course, because we have so many things on our plate, and you know, we're juggling all these things. It takes a while, but it's advancing. I assure you, people out there. I know we are keeping quiet and we're, you know, making not too much noise on the research side, but a lot of things are happening in the background, and eventually we're going to release some of that stuff. One of the issues is that there is a certain amount of difficulty in publishing. You know, we're getting somewhat censored, and that's really difficult. Hopefully that's going to open up in the next few years and get easier as we gather more and more momentum and more support, both from the public at large, but as well from the academic structures. There's so many physicists interested in helping us at this point, and it's exciting. And more resources we have, more we're able to like bring people in and get help, because we're publishing and we're taking on very complex and difficult part of physics that can make it, that requires, large teams of physicists to work together and supercomputing power and so on. So, I mean, currently Amira is working on Lagrangians and Monte Carlo simulations that require supercomputers for rendering and so on. So, having the resources to be able to do this is really critical. But we have a first, few members of a very solid, powerful team, and it's really excited to see that, especially for me after some 30 years of being the lone wolf, or 25 years of being the lone wolf by myself, scribbling on pieces of paper everywhere. It's really great to have this type of support and to see, the evolution that these new minds, these new incredible minds are able to bring to, to this little baby that I had been nurturing for all this time. So another team member, this one coming from the French department, all the way from France. I'm really excited, probably the most perseverant person I've ever met. The poor guy had to chase me down for years and, insisted on helping and, did a lot of work when we couldn't afford to remunerate him right away and so on. And, really dedicated person, amazing mind, amazing team member, great person altogether. Olivier Alihida, his last name is a little difficult to pronounce for me. It's really an honor to have him on the team. He's very rigorous. He holds a PhD in nuclear physics and he has a really incredible mind. I think one of the quality I admire the most about Olivier is that he's able to have a very rigorous approach, and a very strict, rigorous approach, and at the same time contemplate very advanced, very complex, very out there concepts, completely outside the box, and be okay reconciling these two within his capacity. And it's just remarkable. It's remarkable to see, because it really is where science should be. I think Olivier is one of the greatest example of where scientists should live in their own mind, meaning they should be rigorous as it needs to be, but be open-minded. See, like skepticism is commonly confused with closed-mindedness. So people that talk about being a skeptic are commonly actually just closed-minded. Anything that's new that comes their way, they just get rid of or feel uncomfortable with, and they in many cases don't want to even look at it. Olivier is absolutely not that way, and actually is great at exploring new ideas, but at the same time being very rigorous in the way he does it, and having the right amount of skepticism, which is really critical to our team, to make sure that we are always, in the right context, so that what we put out there is solid. So Olivier, here's the world to you. It's great to have you on the team, and I really am looking forward to further work, and I'm really happy to have you part of the Resonance Science Foundation.
Thank you, Nassim. It's very too much compliment for me tonight, but thank you. And for me, it's very interesting coming from a traditional academic courses, and to be able to break all the boundaries, all the classical boundaries, and to see a very open mind new theory, your theory, Nassim, which explain a lot of things in a different way and in a simpler way. And it's very nice for me to jump into the team at this precise moment, because you are switching from the theoretical physics to the applied physics with the arc crystal and the other technologies we are developing at the lab. And it's very challenging, and it's very promising with all the results we are getting with William working at the lab and playing with the crystals and seeing important results, and seeing how it works and how the technology can be improved. So it's very challenging doing both theoretical and applied physics, and seeing the weekly improvement in both fields. And I don't know really what we can disclose yet, but there are really promising things for next year, and I'm really looking forward to do a lot of work with the team. Thank you. Thank you, everyone.
Thank you, Olivier.
Olivier, are there any, I know the research team, besides writing the papers, are also putting out on Resonance Science Foundation really just the exciting breakthroughs that are happening in science all the time, which for those of you who haven't been to resonance.is, that's the place where you'll see these researchers are constantly letting us know about breakthroughs. And is there anything from this year that you feel especially excited about that really relates to what we're doing with the Resonance Science Foundation, something?
Yes, a great point is viewing how science is improving, and with more observation, more data, they are changing their mind, saying that dark energy, dark matter, for example, is not viable anymore, and they are understanding slowly, but they are understanding that they must look at another way to look at things, and so globally it's positive, and it's very interesting to witness this, and on a daily basis, because it's very promising. Yeah.
Thank you, Olivier.
Very good, Olivier.
Thank you.
Yeah. So what Olivier was saying is that it's exciting, and promising, with this wonderful French accent. And so it's wonderful to see. Actually, there's so many things that, like Olivier was talking about dark matter, dark energy. You know, years and years ago, I predicted that these particles would not be found, and they haven't. You know, the mainstream is finally starting to give up on this concept, and starting to look deeper into the physics that are already there to see where the errors may have occurred. And in both cases, the vacuum fluctuations at the quantum level come in play. And this is what Amira and Olivier and Ines and William are working on with me, is to actually describe this missing mass in terms of vacuum fluctuations. Because when we're looking at a galaxy, the reason why we're missing 80% of the mass of the galaxy, which we call the dark matter that's missing, is because we're actually assuming that the matter we see in the galaxy is the only dynamics that makes up the galaxy. We're ignoring that actually the vacuum structure itself is the fundamental dynamics that makes the galaxy, with the black hole in the middle. And the matter that's in it is only actually a small percentage of the mass. It's only the stuff that's stuck in the superstructure of the vacuum smoothie that's occurring in that region of space, if I may call it that way. And so, you know, it really, you know, we're working on describing this. For the dark energy part, as I was saying earlier with Amira, we've solved some of that, showing that we can get dark energy basically from the vacuum fluctuation if we expand a proton to the size of the universe. And we look at the vacuum fluctuation that was in that proton when we started, at the time that, by the time it's the size of the universe, turns out it's the exact mass density of the critical limit of you know, the energy of the vacuum that we measure at that scale. So basically, we account for dark energy, which is a large portion, some 70% the mass of the universe, using vacuum fluctuation. It's very accurate. It does a really good job. So that's a good start. On the dark matter side, we need to work some more, but the concepts are there, and you know, we see where it's going, and it's really exciting. And so more work has to be done there, but it's great to see. And this is why the Resonance Science Foundation, under my direction, has started to publish all these news articles. And I hope the public out there appreciate this. We post articles almost every day on the news that are occurring in physics out there, and we comment on them. Sometimes just short comments, sometimes we write full articles on them. You know, things that are exciting, things that you can stay up to date on by just coming to our website every few days and checking out the new posts that we put out. And but you get the news, but you get the news in the context of a different unified view of physics, and what does those news mean, and how significant they are, and so on. And then you can go and chat about it and describe, and you know, for all the people that are part of the delegate program and go on the boards inside the delegate program dashboards and so on, and discuss it with other delegates around the world. And it's really actually, you know, putting the community to task and to see what people think and where they're at, and to help as well keep everybody on track and have everybody be at the fine edge of what's going on in the world and understanding, because there's amazing things that are going on all around us in the world in science, and it's not always obvious to get the right source for it, for the information, but not only that, to get the correct interpretation of what's being said in some cases in those very technical papers. So we write like little description that gives you a really good idea of what was discovered and how it relates to unified physics. So so another member, and you know, this is one of the newest member of our team, and she's remarkable. You know, physicist with a spine is the way I think of Ines. She's her own mind. She's her own soul, and she doesn't, you know, just go with the protocol if she thinks it's wrong, or if she thinks it needs improvement. And her spirit is very strong and feisty, and she's quite the person. And you know, the way I came across Ines is that she started communicating with us, mostly with Amira at first, earlier on, when she was working in a university, and we're not going to say which one, but where she got a hold of my work, or our work, and she got excited about it because, of course, she found that it was positive and it's a great solution. And Ines holds a PhD in physical chemistry. You know, I love chemists because chemists, you know, unlike physicists, work with the real world. You know, the atoms, the molecule. They talk about stuff that's real, that you know, that you see, that you can, you know, chemical change, all this stuff. It's very real. And so a lot of physicists, you know, don't necessarily get this new view, but chemists tend to get it, because they realize as they work with the real stuff, with the atom, that there's something really remarkable about these things they're working with. There's something really remarkable about, you know, nuclei and electrons and all this. And they realize quickly as well in their study that we don't actually understand them very well. We don't understand what they are very well, and really how they work very well. So they're really honest about this. And certainly, you know, Ines is one of those honest ones. Her last name is, now I'm going to mess that up. So I'm going to try Urdaneta, right? Is that close? All right. So, you know, Ines started to talk to her colleagues and her superior about this work, looking for help in her department in the university. And this is where, you know, it's kind of sad that institutions work that way, but there was a lot of pushback from her colleagues and superiors, and it resulted in, you know, eventually, you know, because of her association or her excitement with some of the stuff we do, and if I'm incorrect, Ines, please correct me. But you know, it resulted in her eventually having to transition, and it's really sad, because that's a sad statement about science. When science is done, it should be that all new ideas are examined and are looked at with even appreciation for all ideas, and an excitement for discovery, and that's so commonly not the case in many of the institutions. And any scientist that tends to wander off a little bit too far outside the box get quickly reprimanded, and it's sad because it's contrary to what science should be about. And so Ines has a lot of courage. She's courageous. She's a person of her own, and she is really like a spirit in our team that I love to have, and I'm so grateful for her participation in our team. So Ines, I let you take it from there.
Yay. We're so glad you're with us, and that's right where you belong.
Yeah, well, thank you for this mindful introduction, Nassim.
My pleasure.
I had already forgotten that part of the story. I feel like it was very long ago, but that happened like a couple of years ago.
Mm-hmm.
And I don't know if it's my signal, which is a little bit slow, but do you see me?
Yeah, we see you great.
Okay. So then, but it was really exciting to find about Nassim's work, because in fact, when I saw his work, it was through Facebook. Someone posted something about this double torus dynamics, and it was very exciting for me because I had been working on parallel with my thesis and my PhD in laser matter interaction. My thesis in France and so I was working in it was specifically in nanotechnology. It was molecular circuits assisted by light. That was my thesis. And so at the same time, in parallel, I was having a rough time with many of the concepts because I was like starting to have like a little bit of difficulties understanding the origin of many of the concepts we had. So just like it didn't stick any longer. So it was like a transition phase in my mind. It was very weird because I was having, I even remember one of my directors saying, but you're like not having the correct thinking about this. And I was like, I don't understand. It was really hard. And so on parallel, I was working with, since I had been working all my life with all my studies in laser matter interaction and light matter interaction, I developed a little like color theory of my own. And the interesting thing about it was that this double torus dynamics that was shown in this post from Facebook was exactly what I had drawn from a different perspective, which was thinking about, was light black or was it white light itself? How would you say that? It was a really difficult thing to explain, but I have a little picture here. So in that sense, when I saw, and I wanted to know what was that about. Was it really physical? Was it something just philosophical? What meaning did it have? And I wanted to develop these equations for that. And so when I saw this double torus dynamics that Nassim had developed, by the way, this happened to me like in 2004. And when I knew about his work, it was 2014, so many years afterward. So it was like I had already forgotten about that. And then suddenly, I will just show, I don't know if you will be able to see it. It's on my phone.
Yeah, that's great.
Yeah. Okay, you'll see that on the right side, there's black and white and potentially white and potentially black, and you can connect them, and it creates a double torus dynamics on, here you have it. Over there.
Nice.
Yeah, but from this point of view, so I was like very impressed because I couldn't believe that this was like the solution or very similar. I had to do the calculations and I didn't do it at the end, but for what's Einstein's field equation, that's the solution of Einstein's field equation with the torque and colorless force. So I was like very impressed, because for me this meant something, a connection really interesting between light matter interaction and the structure of space-time itself. And this connects also with information theory. So I was like really excited about it. I was just like, okay, this is, I've got to know who's this guy and what's this theory and what is it all about. So I started to have like a double life in which, okay, I had my official investigations research, and on the same time I was talking with my friends, my colleagues, and they were a little bit worried because they said, oh, but this guy, who's this guy? And so it was a little bit difficult. But I didn't know no further confirmation for myself. I mean, this was really connected to my own way of thinking and of seeing the universe. I mean, for me, there's no sense in speaking of white or black hole if there's no white. The first time I heard about white holes, it was through Nassim's theory. So, for me, this made a complete sense. So, never mind. It's okay. And now I'm working with them, and as Amira said, in this ionization energy models, and also we were thinking about maybe also adapting this Nassim's model with in order to find a better description for vacuum permeability and vacuum permittivity as well. And what else? And well, with this dark matter model also. And well, maybe I would just like to add that like after I had this problem with the university, I also had been a part of this. There's a group in Mexico called Científicos Anónimos. That would be like the anonymous scientists. These were our mainstream scientists that were like a little bit cuckoo, they would say. And so we were gathering together, and they had meetings with very prominent scientists from Mexico. At this time, there was Omar López Cruz, which is a Mexican experimentalist. Well, he measures black holes. And it seems to me that he was the first, the person who measured, I don't know if you heard about this, 20 billion times the mass of the sun was detected in a measurement for a black hole. And this is the guy who did it. And so together with him, there was a theoretician called Tonatiuh Mateos. This is also a physicist from Mexico. And he's a theoretician. And he was honestly saying, well, 20 billion times the mass of the sun is just completely out of our models, completely. I mean, our models just can't support this any longer. So I had to, and Tonatiuh, which is the most exciting part of it, it's that Tonatiuh, this name is Aztec, is a Nahuatl name for sun. So here we have a person who's called Sun in Nahuatl, saying that they had no idea on how to explain these theories, this experimental evidence with theory, that it was all collapsing. And he said it right away. So for me, it was like, okay, this is not this will not be so hard. I mean, mainstream is already getting into that as well.
Very good.
Yeah, that was very interesting to have this experience with them. And well, that's like, I think I spoke too much.
No, that's great.
If you look at the chat, Ines, everyone is so excited to have you on the call, and yeah.
Yeah. Okay.
Yes. No, that's really good, because a lot of the stuff that we did, in the earlier time with Dr. Rauscher, has not been completely understood, and certainly there's more work that has to be done. And so Ines coming in with her own perspective and connecting with some of the work that was done early on, like the torque and Coriolis forces in Einstein field equation, and then eventually some of the papers we wrote in plasma physics, and some of the paper we wrote in topological physics, where we described the toroidal, the double toroidal structure, and the quaternion and spinor algebra and so on, and we're in the middle of putting all this together. I actually, with the holographic mass solution and everything, and you know, it's been challenging in the context of our resources to be able to like actually, you know, just even have all these guys, you know, here for a few weeks or even a few months, so that we can really move forward and having meetings every day and so on. So it's, you know, so that we can really get this all flushed out, and we can see the link, we can see what needs to be done, but you know, we're all like struggling in our own corner trying to get it done, and you know, there's not like so much, there's so much we can do with the resources we have currently. And so us being able to all come together and have invited physicists like Dr. Rauscher and others to come and discuss with us and help us as well would be so useful and so powerful. And what would come out of it would be remarkable. So, you know, it's wonderful to have Ines on the team. And again, like, her courage is amazing. And her vision, you know, and her capacity is remarkable. And so I'm really, really proud to have her as a colleague. And I look forward to us being able to get together more often and actually work together, and as well support my team better financially, so that people are more comfortable and it's easier for everybody to actually get the work done and not be distracted with having survival issues in all kinds of ways. You know, that would be useful. Because we're working on some of the most critical problems in the world, in terms of, we're not out there feeding children in Africa, but the result of what we do here could have a significant impact on all life on Earth, like in our capacity to survive some of the most challenging, you know, environmental moments in our history, and to be able to like literally feed the world and provide power and provide transportation and as well, we're talking space exploration, we're talking, you know, amazing possibilities that emerge from some of the stuff that these guys are doing, and that no way I could do on my own. And so we're a small team, but we're a mighty team. And
can I add something?
Yes, go ahead.
Yeah,
absolutely.
Because I remembered that there's Berlinde who just said in the recent video, I don't know if you had, right after the Nobel Prize for the gravitational waves, they gave this Eric Berlinde a lot of attention, like, to his theory. And in this video, he literally said, imagine that the universe is a black hole. He didn't dare to say the universe is a black hole, but he said, well, if the universe was a black hole, then blah, 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 blah.
I didn't know that.
Yeah,
wow.
I will send you the video. I mean, it's amazing. He said it clearly.
Wow. At the Nobel Prize.
Well, that was in the it's something called it's like seminars that are given in a university in Canada. It was not, but it was like the day after the Nobel Prize, and it was no coincidence that they were giving him this speech, I guess, because he's like the only one that could like clear a little bit the face of science at this moment in mainstream. So he said, if the universe was a black hole, then no.
Wonderful. Wow, I can't wait to see it. I had no idea.
Yeah. Yeah. No, and then he said, I don't like keeping people outside from people from the outside out of our theories. He said something like that. It's amazing. So I really, in his video, down the description of the video, I said, I hope you speak truth. That's what
Nice. We should connect, you know, and see if we can collaborate.
Yeah.
It's so exciting to see for me. You can imagine you know, Ines, I mean, I was out there some 25 years ago telling people that the universe was a black hole, and that there was black holes in the center of all galaxies. And I was not a popular fellow in those physics conferences saying this stuff. And it was predicted by the theories I was writing. It made sense to me. It made sense to me that there would be singularity at the center of all galaxies, but it made sense to me as well that these singularities would be the driving mechanisms of the galaxy, not the result, which, you know, for many, many years, they thought that the black holes that they eventually found in the center of all galaxies were just a result of star collision in the nuclei of the galaxy. When I was telling them, no, that's the driving mechanism of the galaxy. And now they found, of course, black holes were present prior to the galactic formation. So they're starting to get that view. I'm still, you know, way outside the box when I'm telling them that stars are the same mechanism, that there's singularities at the center of stars, and that the singularities are the driving mechanism that makes that plasma ball we call a star. And that when the plasma ball actually explodes, which we call a supernova explosion, a supernova dynamic, that the black hole we see after is not a black hole that formed as the result of the explosion, but actually that it was the black hole that was always present at the center of the star that is now being visible because the plasma, which is called the orgosphere around the black hole, has been blown off. And it blows off because of mechanisms that are similar to what we describe in the carbon cycles of stars, where certain shells get formed because the plasma cools off, and the shells get formed in the other layers, and pressure builds on the inside, and eventually the whole thing explodes. And then it liberates material in the environment of that singularity, that star, which is now seen as a black hole. And that material gathers around smaller singularities in the structure of the vacuum. And those are eventually coalesce as planets. And this is why exoplanets, planets that were found outside our solar system, were first found around pulsars, which is the remnant, or the black holes that are the remnant of supernova explosion. And all the mainstream, the astrophysicists couldn't believe, like, how can they be stars around pulsars? How can it's such a harsh environment? This is the last place we would have thought to find planets, but that's the first place they start to find planets. And so it was exciting for me because it totally confirmed the model had already developed in star formation and star evolution and solar system and planetary science. And since then we've found that there's planets almost around every single star that we observe. There's actually stars without planets are actually more rare than they thought. And so, this mechanism of planet formation, including for our sun. So people say, well, if our sun is a black hole, how is that possible? Well, of course, if you write the equations and calculate, like the Schwarzschild solution, for instance, for our sun being a black hole would require that it has a diameter, I believe, or a circumference of 18 kilometers. And that's not the case. We can clearly see the sun is much larger than that. So the tendency is to say, well, the sun cannot be a black hole. It doesn't have the correct density to be a black hole. But that's assuming, and I'm going to say it again, and I know, like, eventually they'll get there, assuming that the sun is homogeneous or somewhat homogeneous. And what I'm saying is that it's not homogeneous. The central part of the sun is collapsed into singularity. The singularity is at the center of this orbital system that produces massive amount of energy, and it has accumulated, it has what we call accreted material all around it. And that material is, because the black hole, the singularity is spinning at very high velocity, things can be in orbit around it. Like people say, well, why is it not all getting sucked into the black hole? Well, because black hole actually cannot absorb much matter. They can't, because they're spinning at very high velocity, and it spins the material out. And so there's states of balance between the singularity, and that's why there's black holes in the center of galaxies, and galaxies don't get just sucked into the black hole. It's because when they discovered in the last few years, black holes in the center of galaxies spin at over 80% of the speed of light. This is significantly fast. And you can imagine the Coriolis and centrifugal forces that are involved in such a spin. And of course, and they were noticing that not much matter could fall in that. More matter would be flung out. And then there's the fact that what I believe from the physics I wrote is that not only black hole accrete matter, but black hole produce protons at their event horizon, that there's matter production that's occurring because it's interacting with the vacuum. And these equations of holographic mass are really the first step in describing this matter production at the event horizon of black holes. And so anyway, there's all this gives a completely different picture of cosmogenesis, of what we're living in, of the evolution of solar systems, and eventually the evolution of little humans on them that that are able to actually cognitively compute all this stuff and actually think about it, which is the most remarkable
exactly
about the whole thing, is that we can actually think about this stuff. And that leads me to our next member of our team, which is one of the most popular guys out there. Everybody loves him. He's the best. He's our pillar of biophysics at the Science Foundation, and really does incredible work, on a very wide level, from advanced physics to experimental studies in laboratory, and everything in between, with consciousness studies, and answering questions continuously on the blogs in our academy, and and talking about talking about this work in conferences all around the world, in physics conference, biophysics conference, in consciousness study conference, and so on. It's our favorite. It's William Brown, our biophysicist extraordinaire.
Yeah, and William's even been answering questions on the question level here. He's been working away as everybody's been talking. Thank you, William, always.
Oh, yeah. Well, it's just I'm so glad to be with everybody in our, residence science community. It's just always fun and exciting to engage and answer these questions. And it's probably needless to say that working with Nassim and this brilliant group of researchers and scientists has been one of the most rewarding and amazing experiences that I've had the honor to partake in. So I'm eternally grateful for this amazing experience because, with a predominantly biological background, it was very unlikely, following the normal course of academia that I was following, it was very unlikely that I'd get to do much work with things in mathematics and advanced physics and even engineering. I mean, building alternative energy production devices and engines for starships, star drives. So it's an amazing thing to get to work with this brilliant group of folks with. And so, in regards to some of my background, I was doing thesis work on studying the brain, its connectivity, the information processes involved in its function. And the more in depth I studied this, especially doing experimental based science with it, there's just so many holes in explaining how this amazingly complex system comes together, how it produces phenomena like experience and consciousness. And so I was studying very deeply mechanisms of quantum biology, which was kind of an emerging field at this time. But it was when I met Nassim that I saw for the first time a way to actually get some real answers, some real insights. Because, quantum biology was looking at mechanisms of quantum mechanics, non-trivial quantum mechanical phenomenon occurring in the biological system. Here, though, was a unified field theory, unified physics that could be applied to the biological system. And this was very exciting to me because I saw very clearly how this was a pathway to be able to explain some of these phenomena that are just outstanding questions, unanswered questions, particularly in the biological sciences. And sure enough, working with Nassim over the years, we developed almost an entirely novel approach, what I like to call unitary biophysics, which is applying the concepts of unified physics as developed by Nassim and the physicists working with us to questions of biological behavior. For instance, we have this understanding of the vacuum structure, a informational, energetic, and geometric structure to space itself. Well, we can look at how certain mechanisms in the biological system can couple to that vacuum structure. And this is important for a number of reasons. But if we can begin to describe ways in which the biological system is coupling to the vacuum structure, it provides a very strong framework to explain a number of phenomena. So, for instance, looking at the activity of light and sound at the cellular and molecular level of the biological organism, you can see how acoustic vibrations, oscillatory behavior of biomolecules can not only work in increasing coherence or ordering and structure within the biological system itself, but by information exchange with that vacuum structure. And the same for the emission and absorption and transmission of light, electromagnetic phenomena. And this is all, these are all things that we explain in a very detailed way in some of our papers, like the Unified Space Memory Network. In particular, in that one, we explain the role of water in that as functioning as one of the ordering mechanisms by which the biological system is able to couple to the vacuum structure, that kind of ever-present field permeating all things. And by coupling to that informational structure of the vacuum, it's able to act as a kind of morphogenetic field to shape the biomolecules, shape how they interact with each other. And we explained this in our paper, and then sure enough, there not too long following this, there was discoveries, experimental laboratory investigations showing how water was directly interacting with the biomolecules and DNA and their interaction. Water was mediating the activity at every level. So it was the orchestrating element in how the genetic information was being read and expressed, and then later mechanisms of how the biological system is in communication. And so then we have this on a kind of theoretical basis, but then we are investigating this empirically. We see it in the lab, in the research that we're doing, because we have these resonance-based technologies that Nassim has developed, that the engineers on our team have worked with him to actually begin producing. So we have these resonance-based technologies. We can test them on water. We can then give that water to biological organisms like plants. And indeed, we see all these key markers of seemingly improved coherence, improved informational exchange when you have stronger coupling to the vacuum, which is what we posit is occurring in some of these resonance-based technologies. So this kind of theoretical and empirical investigation lending support to the work that we're doing there is just becoming very exciting. And so in the next year, we plan to take this and just develop it to some of the next logical conclusions that we set up in our foundational work in papers like the Unified Space Memory Network. For instance, really beginning to explain from a scientific approach consciousness, as an example, the mechanisms of consciousness, because you've got that 100 trillion cells that make up, on average, the human body. Each cell comprised of 100 trillion atoms, and then you've got some 37,000 billion reactions every second. Well, those atoms and all that interactivity is entangled. And we know that from the geometrical solutions produced by Nassim and Amira, because the space-time geometry that gives you the mass of fundamental particles, the proton, the electron, but it also describes this connectivity structure. One of the ways you get an exact mass is via this intrinsic entanglement, this intrinsic connection. All those atoms and all that interactivity of your body is undoubtedly entangled, not only intracellularly across the body, but also outside of it. So the connectivity of all things. Well, so the information processes occurring within your system, which have the physical correlates of, billions and billions of chemical reactions and cellular behavior, that information is being shared across this vast network. This vast entanglement network. We've been looking at terms like the entanglement nexus of awareness, where the information, which is supposed to be subjective, the things occurring in your experience are being shared across this system. And on the other side, the system is feeding information into your body, into the information processes occurring within you, kind of like what you would call like a morphogenetic field. And so you get this fantastic unitary perspective, unified view, where things are not isolated and separate, but you need this coherent, unified description or perspective to actually be able to get the appropriate solutions to be able to explain these kind of phenomena. So these are exciting things that are coming up that I'm very much looking forward to.
We love you so much, William.
It's mutual.
It's amazing what you can pack into such a small little space. And for some reason, we had this interesting phenomenon when you were talking. Somebody was typing, but we're all muted. So we have no idea how that's happening. This is some phenomenon. It's not possible because everybody's muted, but...
I never heard it. I never heard any typing.
That's okay. We could hear you, though.
Okay.
We can hear you perfectly. Yeah.
Oh, well, it wasn't me.
we could tell it wasn't you.
Okay.
I posted the link for the Space Memory Network paper that was published at Neuroquantology, William as well, it was cited, right? It was cited in the last few months.
Yeah.
Do you want to talk a little bit about the work these guys are doing? It's really interesting. I think it was cited in a very actually significant paper. I'm really glad to be able to interact with those guys.
Yeah. So the paper that it was cited in it actually made it into a couple of news announcements. I had folks that I communicate with regularly, who are part of the Resonance Academy, and they were sending me these links like, oh, you should check out this news article on these guys who are talking about consciousness. They've got this really interesting paper, and I was telling them we're already working with these guys. They cited our paper in the paper that is being talked about there. But so it's Professor Dirk Meijer and Hans Giesink, I believe out of Sweden or possibly the Netherlands. But they contacted me and Nassim not too long ago, and they were asking about this double torus topology that Nassim, in collaboration with Dr. Rauscher, described. In particular, in one of his papers, spinners, twisters, quaternions, he really gets into the details of this double torus topology. So we began this collaboration with them to begin to map this acoustic frequency scale that they have been investigating and describing, but to be able to map this acoustic frequency scale that is coming from analysis of the biological system. So they have done this meta-analysis of now it's up to 500 papers that have documented the effects of specific electromagnetic wavelengths, frequencies in the body, both endogenously and exogenously. So, they've collated all this data and generated a very specific pattern, been able to pull out this very specific pattern. And the idea is that if we can map that to this double torus topology, it would begin to describe how this pattern of these very specific frequencies are acting as these orchestrating or ordering transmissions in the body. So even in one of their most recent papers, they describe it as kind of like these frequencies as kind of like a pilot wave that is guiding the and intracellular communication or interaction of the body to give it some of that order to help to organize those 100 trillion cells, those 1,000 billion chemical reactions, because that's not happening randomly, right? How is it being ordered? So it's just really exciting to be able to work with these guys, because they have really impactful work. The papers they're publishing are not trivial papers. These are things that are at the forefront of this kind of investigation. And actually, when I went back and looked at some of their publication history, there's more than one paper citing Nassim and Rauscher's work. So they've actually cited Nassim a number of different times. And because I think that they saw very much the same thing I saw, that this unified perspective is the way to be able to explain the processes, some of the processes of the biological system that have not been explained, like consciousness, morphogenesis, these kind of things.
Self-organization, all this stuff. It's so exciting to see that the ball is being picked up out there, and that it's evolving in so many different ways, and that how the path cross between their research and our research, and to have the resources to bring these, to get everybody together in the same room and to like go at it for a few weeks together, be remarkable. It's critical for human evolution right now. And it's like, it's all about getting the fuel. We have, the talent is out there. It's, we have it. It's clear. We know where to go. We just need the fuel so we can go. And it's happening, it's happening, and people we wanted to expose this to everybody so that people get out there, they get that like there's stuff happening in the background, and that we're doing all this work, and it's slow going because it's science, and science takes time and all this stuff, but and that we could move so much faster if we had better means. And so people out there that are connected with possible, support for our nonprofit research foundation and ways to help us, by sharing the information and sharing the link. And there's all kinds of ways you can help us just raise the awareness and raise the resources for us to be able to like really move forward. Because we're competing against teams out there that like are funded with like, billions of dollars in accelerators and all this. And if we could get like, even a small portion of these budgets, we would be probably launching humanity into, exploration of the cosmos, like literally. So so I want to mention as well that this what we presented to you today is only a small part of the research team. I mean, it's the most theoretical part of the research team. There's research team members that are part of some of the work that's being done at Taurus Tech and Arc Crystal and so on, that are engineers that are working diligently every day to help bring application to some of the theoretical work that's being developed, and to bring it to bear so that it can benefit humanity right away, so that it doesn't just stay in the theoretical realm. You can imagine that, for instance, with some of the stuff that William Brown was just describing and some of these discoveries that are occurring in unified physics, that there's application to health, to longevity, to to disease control, to all kinds of things that emerges. The possibilities are really endless, and so it's not just in terms of energy production, application, or gravitational drive, which is already remarkable, but is as well in terms of the possibility to start to understand the body at a completely different level, at the level of the electromagnetic fluctuations that allows this self-organization to occur. And when certain part of the body decohere, when they decohere, typically what they find is that there's a breakdown in communication between cell-to-cell communication and the cell environment. And if we can, by manipulating the structure of the vacuum in that region, recohere that region, bring back, appropriate communication links in the network of the system, we could have, amazing, significant impact on health and certain, healing capability of the body, and on life extension itself, which could be remarkable. And a lot of it has to do with the water molecule, and it has to do with what the water molecule looks like to the biological system. How is the biological system able to interact with the water molecule, and how is the biological system able to absorb the water molecule? And some of the tests that William has been doing in laboratory has been to show, through double-blind studies, that the water structure is modified significantly by electromagnetic fluctuations that we're able to produce in small self-organizing, self-standing crystal, and that these oscillations that are occurring at the quantum level are modifying the water molecule in such a way that it becomes very bioavailable, very energetic, that it has positive effect on biological structures. And that all links nicely to these discoveries that were made that William was talking about in these measurements, showing that the water molecule is what is modulating DNA. It's not just some neutral background, just like we thought that the vacuum is a neutral background. In biology, they thought water is a neutral background. You can ignore it. You can just study the stuff that's in the water. Yet, if you remove the water, the biological structures fall apart extremely rapidly. So they're finally coming to conclude that water is actually the important modulator that is dictating what the biology is doing, and how mapping is occurring, and how information is transferred, and all this. And so learning how to energize water, how to structure it appropriately, and all this is extremely significant, because, for instance, for life longevity, I mean, literally getting old is like dehydrating. You can see there's a little dehydration here. It really has to do with our capacity to maintain cellular integrity in such a way that that the structure of water does not break down in the cellular structures, in the membrane and intermembrane structure of the cells, and we're right on that path. So really, it spans large application protocols from energy production to biological physics and to health. So all this is being worked on with a fairly small team, and we'd love to be able to expand our team, and especially to spend more time all together and support each other that way, so that we can move faster, publish more papers, and interact with other teams around the world that are on the same path, and support each other, and really contribute to society that way.
Hey, Nassim, I just posted some links. I've been kind of doing it the whole time for anybody on the call or listening on Facebook Live or listening to the recording. One, you can start your exploration with the Academy with our Explorer Path for free, and that's where you can see all of the science news posted. You get clips from our Live with Nassim, our faculty Q&A. The articles are there. So that's one place. If you just want to get started, you can go there. All you have to do is put your email address in, tell us what you're interested in, and you can start your process. And for anybody on this call or listening to the recording or on Facebook Live, between now and the end of the year, we're giving you 20% off joining the delegate path, which is where you're with us every month. You're live with Nassim, faculty Q&As. You get all of the materials, a really cool dashboard. Lots of new electives are coming up. And I put that link in there too. Solstice 20 is the coupon code that you put into the checkout. I've also put links to our support RSF page. And we reached out to our community just recently, as Nassim has been saying, in order to really get this worldview out there and to support the research. We put together a whole set of pages that shows you how you can help. Anything from helping us on social media to share the word, and anytime you see posts on Twitter, Instagram, Facebook, that you share them with your friends. We extend our reach. Signing up as a volunteer, there's a volunteer form there. Making a purchase, joining the Academy is a great way to do that, and also making a contribution. And we made some really wonderful gifts. So at whatever scale that you can give, there's some really lovely gifts that we wanted to give back to say thank you, because it's really going to take all of us to really break through and get this out into the world in a powerful way. And so all of those links are there, and I'll keep posting them so that we have them. And I wonder if, Nassim, if we just want to go and get a closing comment from each of the researchers. I know people were really happy to meet the team today. I could see in the chat that everybody was so happy to see everybody. And then maybe you can end us with a little centering or some kind of solstice blessing. How does that sound?
Sounds great. Yeah, let's go through
through the team. Okay, great. So here is Amira again. Any closing comments from you?
Well, just to say thank you to everyone for all your support, always. And also just to mention, well, at least in my experience, I think this goes for all of science, but at least in my experience as an astrophysicist, you would have like teams of thousands of people, or maybe I'm exaggerating a bit, hundreds of people studying one star. So there's like a very small team of us studying everything. So you can imagine, I mean, just to get some perspective, how it can be quite time consuming, because literally a whole team of people across different continents would be studying one star. So I hope that gives you some perspective, and thank you for all your support, and happy solstice. Enjoy the rest of your day and enjoy the longer days that are coming, and thank you.
Thank you, everyone. It was very nice to be with all of you, and I wanted to add that we are not alone, and we are with you, and we are also connected with all science proceeding all over the world, and with the science news we give you a little feedback, but the most important part is that we are taking all this data, all these experiment results to confirm our theories and Nassim previous work and future work, and it's all connected, and we will have very interesting news for next year, interesting results. Yeah, thank you everybody.
Thank you, Olivier. And let's see, Ines, I'm going to go to you next. I got to find you to spotlight your video. Here we go. All right, here we go. Nice to have you join the team, Ines.
Thank you. I would just follow like Olivier's comment. If you follow news, scientific news all around the world, you will see that this is happening really fast. They're having they measured entanglement in macroscopic material. I think it was diamond and things like that, and it's happening everywhere. So I'm confident that we will have support like mainstream, like not so far from now, and I want to thank everyone and my team, my beloved team. So I'm very happy to be with you guys, and just have a beautiful solstice and beautiful dreams for tonight.
Thank you so much, Ines. It's really lovely to have you on today. And William.
Thank you everybody for joining us, and hope you have a great winter solstice. Happy holidays and New Year. If you enjoyed some of the discussion you saw today, and you'd like to see more, get more information, and participate more, there's a number of different ways to do so. For instance, via the Resonance Academy, where there's a lot of excellent content, and that content is always increasing, especially with a lot of the new research and information that we've been producing. And it's also a great place to get to chat with other like-minded investigators and researchers. And so I hope that we can continue to explore these fascinating subjects together. So thank you all.
Let me just say somebody asked about gift certificates. Somebody wanted to sign their son up or their nephew. So I posted a link. It's to our purchase page where we have gift certificates for that. So you can get them there. I'm just going to post that link one more time. And Chris, I wanted you to make a closing comment. And then I also have Maura on, who is going to share about our next delegate gathering to Peru. For those of you, we went to Egypt this year, and next year we're going to Peru. So Chris, how about a closing comment from you, and then we'll jump to Maura and then back to Nassim.
Amazing year, amazing people, an amazing community, an amazing call today, incredible depth, incredible information. It's always so inspiring to hear from this group and from this community. I wish you all a wonderful, incredible solstice day and celebration with your family, both those that you choose and those that you got, and enjoy it. And much love to you all.
Thank you, Chris. Thank you so much. Thanks for all your hard work there. And Maura Hoffman, she's part of our Resonance Academy team, and she's been helping to put together our next trip to Peru, and just has a few things she wants to share about that.
Thank you, Teresa, and happy solstice to everyone. And what a beautiful day to get to let the public know that we are all going to be taking the delegates to Peru, Machu Picchu, Sacsayhuaman, and once again, taking people into places that are off the beaten track. not the usual, typical tourist places. We're going to do some very, very special things, get very special permissions, even head over to Bolivia. So we're getting all those details together now. Mark your calendars for October, November of 2018. And with those gift certificates, what a great way to bless someone for the holidays, to let them know they're being invited on a trip to Peru next year with Nassim Haramein and the Residence Academy, and a great incentive to become a delegate, because that's our big annual celebration together. Happy Solstice, everyone. Lots of love.
Thank you. Thank you, Maura. Great. All right, Nassim, back to you. What a great call today. I'm so excited everybody got to meet our team. It's so good.
I just get blown away every time I look at my team, at our team, and how this amazing, manifestation that has emerged out of the field, and here we are. And it's remarkable. And I'm so honored to be part of it. I'm just humbled to be part of this amazing, community, our team, all the people out there with this interest, like the growing community that's occurring around the world. I'm so grateful to all of your participation, of course, all the team members, but as well, all the people out there that have this interest and that is sharing this information. And, this is a time of the year where we share, this is the time of the year where we gift. And what is the best gift than a gift of knowledge, of a deeper reality that we live in. And, and it is my wish. I can get a little melancholic around this time of the year because, there's a sense of separation. There's a sense of aloneness that can emerge at this time of the year for people, and to really, when you feel that, whether it's at this time of the year or any time of the year, to actually feel the connectivity right there, right below that sense of separation is this incredible sense of belonging. And when I talk about the connectivity, it's not just the connectivity, but it's actually the support, like the feeling that you're part of an amazing network of information and that, like a universe that's just cheering you on, that's just your best cheerleaders. That's like doing everything, like putting billions of atoms together and cells together to make you explore and go deeper and transform and grow, and and this amazing opportunity to grow, that we're constantly confronted in. I don't know about you guys, but for me in my life, and this possibility of growing individually as individuals, but in our consciousness, in our awareness, and our ability to have empathy, to feel this empathy, to feel this connection, at the deepest level, like maybe taking time during this time of the year to actually sit and contemplate, and just connect, and feel this support from the universe, this empathy. And then this transformation that we feel internally, then to externalize it, to express it in our world, to make this beautiful, being that you are inside, this master, and to actually transpose this mastery in your world all around you, to gift it to the world, I think is the gift that that really keeps on giving, and that really you know, is the gift that I want to give for this time of the year, for this solstice, to do my little share in the beautiful transformation of our world, in a world that lives in chaos and scarcity, to a world that lives in coherent abundance and in support of all, as a global community, as a truly transformative global community that we are becoming, like the caterpillar becoming the butterfly. And so on those words, I think we must close the call, but I wanted to wish everybody the most transformative, the most beautiful, the most connected, the most transcendent moments at these celebration time of the year, and let's birth the world in 2018 into a path of transgression, into transformation and transcendence, into a world that is sustainable and abundant. And until then, may the vacuum be with you. Happy
Thank you so much. Thank you, Nassim, and all of our research team. I'm going to see if I can, let's see if we can actually see everybody's video at once. Hopefully that's what's happening on the recording. But thank you all. Happy solstice. Thanks for joining us in our virtual classroom, and I hope you come and play with us more. This is going to be a fantastic year. See you all soon.
Thank you,
Blessings, everyone.
Blessings, everyone.